G'day everyone. Well, here we are again. This weekly Sunday event. Hope you're enjoying these Toolbox Tech Talks. Keeps me busy on a Sunday. So today's a bit of a special one for me. I've got some guests that I've known for a very long time, and I'm going to introduce both of them one by one. So my first guest today on Toolbox Tech Talk has been working in the solar and battery storage industry for over 3 decades. So he's really knows the industry well. He's got a previous background in UPS systems, including things like lighthouses, telemetry, police, CFA radio. But 3 years ago, he founded the 100% Australian-owned PowerPlus energy company, making premium lithium battery modules. So it's my pleasure to introduce my good friend Bradley Paton of PowerPlus Energy. Bradley.
Greetings, Mr. Morris. Thanks for inviting us.
If I can get Bradley on, I've got the wrong person. There you are. Got you, Bradley.
Greetings, Mr. Morris. So you didn't show Craig. You didn't show the other gentleman first, did you?
I did. That was just a fumble of my buttons. But anyway, I better cut to Craig. So he's sitting in the background. So Craig, it's my pleasure to introduce Craig Hunter. He's the BDM for PowerPlus Energy. Craig's been working in the industry for a long time too. So what have we got? 15 years with Cell Electronics, 6 years with SI Clean Energy, and 2 years with PowerPlus Energy. So g'day, Craig.
G'day, Glenn. How are you?
Yeah, I'm good. So, how are you going in lockdown world? Are you stuck in a room full of batteries by the look of it?
Yeah, that's my favourite hangout spot, basically. So, no, lockdown's going well, enjoying the homeschooling with the kids, and actually enjoying to be able to spend more time with the family. It's actually really good.
And how's that wonderful leg of yours going?
The leg's going well. After Brad pushed me down the stairs, spent about 9 weeks with a leg up, but no, the legs are healing quite well.
What were you doing on a motorbike, riding down the stairs?
Just trying to get away from Bradley. He was coming up to me with sales targets and the like, so,
Am I allowed to respond to that?
Go for it, Mr. Push.
Well, I say, since Craig has been working for us, I think he's had more annual leave, or working from home, as he puts it, than he's been in the office. We've got a photo up on the wall, so we haven't forgotten what he looks like.
I think this is just the new normal, isn't it? We're all elsewhere, but we're kind of together in some way. And that's kind of what's happening with these Toolbox Tech Talks. I'm bringing you all together in the virtual world. Yeah, so let's just dive into it. Tell me a little bit about why you started PowerPlus Energy, Bradley.
Well, as you said in your intro, for the last 30 years, my life has revolved around batteries and energy storage. And while lead-acid batteries have been around for a long time and we know how to use them and we can take advantage of what they have to offer, with the advent of lithium, it addressed some of the challenges of using lead-acid batteries. So about 5 or 6 years ago, we started researching what was available on the market, what the different technologies and approaches to using lithium as a replacement, and that culminated in us deciding that the best way to do it was to build them here ourselves.
So you've been through the battery industry and the lead-acid world for a long time. Anyone who's been around for 30 years must have done a lot of lead-acid. Was it tough to let that go?
I still think lead-acid is a viable energy storage medium for some applications. And so, what we try and encourage installers to do is to look at what the customer actually needs and choose the right solution. So, sometimes it'll be lead acid, sometimes it'll be, lithium ferrophosphate, sometimes it'll be other chemistries. You just have to choose the right solution for the application. So, no, I'm not sick of lifting lead acid batteries. That's one part I don't miss. Look, there's a lot of advantages in using lithium, and we've sort of focused on those areas.
Cool. How about you, Craig? Do you miss the lead acid days?
Look, Yes and no. The lead acid days generally was better when you're trying to fault find a system. You actually could send them on a bit of a wild goose chase looking for battery connections and those sorts of things. But with lithium batteries now, just for the simplicity of installing them, there's not really in many areas of connection points that can go wrong. So it's actually an enjoyable experience when you're supporting people on the phone.
I think you touched on the things I really enjoy about working with lithium too, which is that they're not so heavy, and I have injured my back from lifting lead acid batteries, but also the fact that they're so modular. You know, I'm not stuck into telling the customer they need an X size battery for the next 10 or 15 years. You know, I can say, well, let's give you what you need now, but you can upgrade later on. Now, that isn't always a true story, is it, Craig? In terms of upgradability? No, it's not.
Yeah, 100%. It depends on the batteries that you buy with the lithium batteries, and depends on the roadmap that the manufacturer has in regards to whether they want backwards compatibility once they release higher energy density or new communications in their batteries. And it's one of the things that PowerPlus Energy has a pretty strong point about with backwards compatibility. So it's one of the first design criteria when we design a second or third generation of battery, on the ability to still be able to put them into older systems or systems of generation 1 batteries. So
I've got some of your first generation life batteries, and now I've also got the newer version, so they will work together.
Yes.
Correct. That's the idea, yes.
Okay, that's great.
The industry focus has very much been on energy density and price. So the energy storage has been driven primarily by the EV market. And so having something that's compact, high energy density and low cost has been the focus of the industry. I think we approached it from a different angle. It was more about ease of use and reliability and longevity. And so while there are some compromises on the energy density and price, the goal for us, and I think we've achieved this, is a better user experience for energy storage applications.
Great. Now, I just want to remind the audience that you're welcome to ask questions by just typing them into the comments field. Now, I can bring them on screen and our guests can answer them, but it's probably worth just checking your spelling and that you've written what you wanted to write, but keep it short, 2 or 3 lines. And if you want your photo to appear, you've got to click a little permission link, I think, in Facebook land to allow your photo to appear. Otherwise, it's just a silhouette. So feel free to type some comments in there, and I'll pass them over to the guests. Now, Bradley, I've actually got some pictures of your products. It's probably worth looking at them and talking about them rather than just talking about them. So I'm going to bring those up on screen. Hang on, here we go. Now, I've actually got Craig up in the top corner there. I don't know if you can see. So this system here, we've got 2 systems. Craig, can you see the picture of the systems?
Are you talking about in front of me now? Or
Yeah. I know.
Yes, I can see them. Yeah, they've come up there. Yes, I can see them on Facebook.
Do you want to tell us about them?
Yeah, so the systems here, I guess, one of the most popular inverters that probably does get used in a lot of quality off-grid systems, it's got this electronic SP Pro in there. When it comes to regards to the battery side of things, Glenn, you've got some of our Life Premium batteries there in the image on the left-hand side, on the right-hand side, where it's in our indoor enclosure. So with the enclosures that we do in those indoor variety, they come from an 8-module up to a 20-module cabinet, pre-wired and pre-assembled, ready for easy installation. And it looks like the system there on the right-hand side, they've gone for a cabinet that's got expansion room basically inside it. So they've obviously bought 6 or so batteries, and they're going to expand at a later date.
Is that a weatherproof enclosure, the one on the left, the white box?
Yeah, the one on the left in the white box is an IP56 rated enclosure, so it's a weatherproof enclosure for outdoor installations. And they come in either a 3 or a 4 battery module cabinet, basically, for easy installation. And they're actually quite popular for some of the smaller off-grid systems that we see going out there, especially for holiday homes and small little I guess, like the caravan sort of style market.
Great. We've got our first question. I'll put it to Bradley, actually, and I'll just bring it up on the screen, Bradley. It's from Brian. Brian says, have PowerPlus Energy been in talks with EvoPower as a replacement battery for LG Chem?
We're happy to work with anyone that would like to use a self-managed LFP battery. But I think Evo's focus at the moment has been on the LG Chem. It's sort of a technology they're familiar with. But as we'll sort of show you later, one of the beauties of what we do with our battery design is we're fairly flexible as to what hardware we work with. But come on down.
In fact, you're just around the corner from each other, aren't you?
Yep, it's just up the road at Croydon.
Wow. Okay. So this kind of brings me to the next point, is it's an Australian-made product, isn't it?
Yes. Yes, we obviously we have to source our lithium cells overseas. However, the metalwork, the labelling, the packaging, we use Australian-made cables sourced locally here in Victoria, and we employ 42 people now. About 30 of them are involved in the production side of the business. And so all of our cable assemblies, everything that goes into the battery is built here in our factory in Bayswater.
Wow, cool. All right, I'm just going to go back to looking at the product with Craig. So the next slide is just looking at the Ecos battery. Now, you've got sort of two main streams of products. Would that be true?
Yeah, 100%. So we have the Life 33P, or the Life Range battery. Basically what that is a premium battery. It comes with a bit more of a premium performance and warranty over what the Eco has to offer. So the Eco battery is still using the same sort of high quality cells, goes through the same test process and the like. The difference is the battery was built to target more of the mid-range sort of offering products that you see on the market. So when you look at some of the competitors on the market, they're offering things like 60% remaining capacity at the end of the 10-year mark, and they're offering things like a two-hour discharge rate maximum. And that's where the Eco is designed to compete against, so in price-wise and performance-wise. And with the Life battery, with the Life battery, that one there is more competing in more the premium end with a 1 hour discharge rate and an 80% remaining capacity at the end of the 10-year mark.
Sorry, Craig, I think I probably got the switching of the pictures around the wrong way, but the labelled on the front there, so Eco is white and Life is black, and the Life is the premium end of the spectrum. That would be the summary, wouldn't it?
Correct, yeah, 1 hour discharge rate basically, and a more premium warranty.
Yeah. Cool. We got a question. It's from my good mate Ian. So hang on, I'll just bring Bradley for this one. So Bradley, Ian asks, how much usable storage in kilowatt hours would you get with the 4-cabinet IP56 cabinet? I think that was the white wall-mounted one. How much storage would you get in usable kilowatt hours?
The term usable kilowatt hours is a little bit flexible in the marketing sort of speak sometimes. With a lithium, as with any energy storage, the capacity of the battery is what you get when the battery is brand new. So we know from the research that we've done and the research that's available generally on the market that a good quality lithium cylindrical cell will cycle 100% at C1 about 2,700 times. If you discharge the cell to 80%, then depending on how you use it, conservatively you should get 4,000 to 5,000 cycles. So and then if you discharge at 50 or 60%, then you should get somewhere around the 7,000 to 10,000 cycles. So it's sort of, we limit the discharge to 80% so that you achieve your 3,650 cycles for the 10 years. But if I wanted to put my marketing hat on, then, and I didn't show you all the fine print, I could say that, yeah, you'll get 10,000 cycles, out of those cells, which is practical. It's quite realistic to achieve that, but I don't know whether it's being totally upfront with customers if you say, oh yeah, 10 years and 10,000 cycles.
So what is the most honest way of describing the capacity of a battery system over its life?
I think the most important thing to do is to look at what the customer wants to achieve. So if it's an off-grid system, typically you're going to cycle the batteries maybe 50%, once a day, except for bad weather. And so to me, it's more about, is the customer going to achieve what they are expecting in the life of their inverter and their solar panel and their battery installation? So it's a different question than if you're doing grid tie and you'll want to be self-consuming every night.
Basically, Glenn, with our batteries come with a nameplate of the 100% rating. So with that four battery cabinet, if you put ecos in there, you can essentially fit 16 kilowatt hours of total storage capacity in there. And our warranty says that you can go to 100% depth of discharge. However, we don't really recommend that in any installation, because when you go to 100% depth of discharge, you're relying on the battery now to turn itself off rather than the connected inverter connected to it to control the turning off. So we highly recommend people turning it off at 80% DOD, which means that you get about 12 kilowatt hours of usable energy out of the 16 kilowatt hours of total energy capacity when you're using the ecos. And similarly, if they were the life batteries, you would get 4 times 3.3, which is about the 12 or so kilowatt hours total energy in the cabinet as well.
Thanks, Craig. Ian's got a follow-up. He says, it's probably a comment, but I've got a question to go with it. He says, I like to keep my batteries for a long time. I know you do, Ian. And he's got some lead-acid batteries that must be getting on 20 years old now. I can't remember exactly when they went in. So I'm happy to spend a bit more to get longevity. Now, what is the time warranty on your batteries, for instance?
The warranty is a 10-year repair or replace warranty for the mechanical aspect of it, so damage or anything like that. Yep. And it comes with a 10-year performance warranty as well. So the performance warranties, as I sort of mentioned before, it's 10 years as long as you use it within our specifications and our terms and conditions. So with the Eco, 2-hour discharge rate to 80% 80% DOD, we guarantee above 60% state of health at the end of the 10-year mark.
Yeah, if I throw my perspective on this too, there's a lot of factors, as Bradley pointed out, in terms of what the customer requires. I often, point out to them, do you plan to be in this house for 10 years? Do you actually want to invest in something for the next owner? So that's a consideration. Is it actually permanently occupied? So if it's a holiday house, they're not going to be cycling it every day. So it's probably just going to be the lifetime warranties that main concern. Do they actually want to overinvest at a time when prices are going down and down? So, I noticed lithium battery prices have trended down over the last 5 years. I presume that will continue somewhat. So, do you really want to invest in something with a super long life when it will probably be very cheap? So there's a kind of like an optimum time period probably. I don't know what your thoughts on that are.
My thoughts, I guess, is people keep talking about lithium batteries coming down in price, which is true. As manufacturing scales up, economies of scale do bring price down. However, it's marginal compared to what people were sort of speculating. So a lot of people were speculating that energy storage over the next 5 years is potentially going to be 25% of what the cost of it is today. Most of the cost reductions you've seen in energy storage over the last sort of 5 years, immediate 5 years, has been margin erosion. It's been distributors going from making 40 basis points to making 15 basis points to making 10 basis points on the reselling of the product. It's been from manufacturers going from making 80 or 90% basis points to making 35 or 40% basis points. So, and the same as the cells, and the same as people doing the metalwork for the batteries, because they really see it as a growing industry and they're investing in it through margin erosion. So it's not really done through, it's now actually cheaper to make the lithium battery as such. It's just margin erosion as you see at the moment.
Right. Yep. Okay. It's volume drives costs down in efficiencies and, like you say, margin. So let's go back to sorry, Bradley?
I was going to say, you also have the other factor is that some of the other input costs are going up. So transport costs are higher, insurances are higher. So it sort of counteracts it in some instances.
Right. Let's go back to the slides. I've still got a few more pictures to run through, so I'll just bring that up. So we've got Craig up in the corner here. Now, we looked at the Eco and we looked at the Life, and you also do what looks like a car battery.
Correct, yeah. So that's our N70 range, I guess that's what we call it. So they're designed for predominantly, I guess, street lighting or lighting applications, for caravan and camping, for four-wheel drives as a secondary battery, and those sorts of things. They come in a 12, 24, or 48 volt options. They're basically if it's a 12 volt, it's 100 amp hour. battery in total size, or 1.3 kilowatt hours, roughly. And they're targeted at that sort of more sort of mobile or smaller applications where the life or the eco batteries can't really fit.
Right. Now, you've got some clever ways of joining up a lot of ELV batteries. So I see you're using the Links system. Yeah,
the Victron Links was brilliant in the when we first started making the batteries. It wasn't a vision of the company to be selling lots and lots of cabinets. So the Victron Links was just basically something that was brilliantly already available off the shelf, which gave us a quick and easy bus bar system to put into the cabinets and get them to market very, very quickly. And as Brad's the product leader of the product development team at PowerPlus Energy, we're moving to our own bus bar system inside now. Main reasons for that is we're now in control of our own destiny and those sorts of things. But the Victron Links are still obviously one of those great sort of things that makes things easy to be plug and play.
Yeah, indeed. Now, on a more serious note, I believe you've had a battery fire.
I'll leave that to you, Bradley.
Well, technically, I mean, yes, we do try to blow things up, but this was a customer's efforts to. They didn't move the batteries out of the way of the bushfires back in January, back in New South Wales, and so we're a bit worried what was going to happen to the batteries. So he took some photos during and afterwards. I think you've got copies of them there.
Yep, they're on the screen.
All right. Yeah, so I can't see the screen. So when he was allowed in a week later, he was like the switchgear and everything had all been melted off the wall. But when he opened the cover to the batteries, the blue lights were still on. The batteries were humming away nicely. They'd survived the bushfire. So they're the sorts of fires we like to survive.
Craig can probably see the picture. So it's three shots. One is just of the decimation of the whole forest around the house. Then there's the battery cabinet closed. You open the door, and inside there is three happy little life batteries with the little blue lights on going, we're fine.
The customer's over the moon. And see, that's one of the things in not focusing on energy density, because we use the cylindrical cells and they're mechanically more robust. They can handle the higher temperatures, and not that you're buying our batteries to survive a bushfire, but it sort of indicates how they're going to work in higher temperature environments.
Great. So last picture, you're one happy customer indeed. I didn't put all the pictures you sent me. The rest of their gear was all melted, so they've got some batteries, but the rest of it looked pretty sad. Okay.
Bounce back as well. I'm not sure on that one.
Oh, really? Okay. So the last picture I've got from you is actually of your new or testing the high voltage configuration. So you've been doing 48 volt life and ecos and also now some 120 volt life batteries. But tell us about this stack. Now you can't see it, but it's those big metal silver cabinets.
I can see it behind Craig's beautiful face. Part of the vision was to be able to offer an easy-to-use or easy-to-manage battery for all applications. And so 2 years ago, when we started developing our own BMS board, actually nearly 3 years ago, the goal was that BMS board could be used for anything from 24 volts up to 1,000 volts. So first off the rank, obviously, was the 120 volt for Selectronic, and we've had those in the field now for just over a year. And so for about 8 months, we've been testing 500 volt solutions by connecting the batteries in series. We've recently installed our first beta unit in the field, which has been working quite nicely. And we've got 4 more going out in the near future. So hopefully by early next year, we'll be able to offer AC coupled bidirectional batteries, and look at some of the inverter products that are being offered in the market with 400 volt plus DC buses.
Right, so you're really covering the full spectrum from the small hybrid on-grid, small off-grid to commercial scale systems here.
Yes. Right. So The advantage, though, in how we're approaching it compared to some of the other solutions available is you can see from the photo that it's highly modular. So whether that's going into a business or into a multi-storey office building, or whether we're doing 1 megawatt, 2 megawatt hours in a shipping container, we can be used the same modular system for ease of installation, ease of maintenance, and lots of pretty blue lights.
Good.
It's basically, Glenn, a plug-and-play solution. So similar to when the guys buy battery cabinets, they slide everything, plug it in, connect it up, and then they would liaise with our commissioning team to get the communications going, and away you go. So inside that cabinet there, Glenn, so you can see it, it's got a 30 kilowatt three-phase inverter in there. It has a UPS for all the communications. So if the system or the site does go down, there's a UPS in there to run the communications, so it can still be diagnosed remotely. And it has 3 strings of 512 volt batteries basically in there is what it has. Each one has its own external BMS and contactor control. So if one string chooses to drop out of the circuit, the rest of them still keep operational.
Good. Thanks, Craig. Look, just take a pause for a moment and talk to the audience. We've got quite a few people out there at the moment, and I just wanted to remind those, particularly those just joined us on this live event, that you're welcome to ask questions by typing them to the comments field. So please feel free to put those in there. Check your spelling and your syntax, because I can bring them up on screen. And if you want your photo to appear, you've just got to click a little permissions button in Facebook land. I'll also be republishing this via YouTube for those who don't have access to Facebook or prefer to watch it in a different format later today. So you'll see it there as well. Now, coming back to Bradley. Bradley, what are the advantages of making a battery in Australia? I mean, I thought we don't make stuff here. It's just too expensive.
Well, I think partly we started out because it was easier for us to do our own R&D. But as we've progressed, one of the big factors has been for us is quality control. Having control over the components that go into the battery, having control over the quality of the assembly. And something that's a little bit unique to us is every single one of our batteries is fully tested, charged and discharged, and checked with a thermal camera before it goes out the door. So we've had a very, very low failure rate. And so it's about quality control. There's part of me that likes the idea of just supporting Australian manufacturing. It's, we get accused of it being a little bit cute, but as I said, we employ 42 people. We support local metal manufacturers, so there's sort of another 15 or 20 jobs that we support. Local printing, local packaging. I just think it's important to try and sort of feed back into the community, into the industry. The advantage for us, though, is it also allows us to be fairly agile. If there's a new feature or a compliance, it allows us to respond very quickly. We're doing a couple of export projects where the customer's incumbent battery supplier had quoted them 18 months to develop a new product, and we were able to do it in 3 months. And it's fun. I'm enjoying it still.
If anyone's ever come to the factory, you will probably notice that the factory gets rearranged about on a bi-weekly basis. So we get some Zoom meetings at the moment where Bradley takes us through for a factory tour to show us what's changed, and it is different every time he does a factory tour for us. So it's a great project, I think, that Bradley likes, because he likes moving furniture around, he likes coordinating it, and I think that Bradley really does enjoy sort of just seeing things, dreams come to fruition. And if you're manufacturing offshore, you're not going to get that sort of experience that Bradley's getting.
There's a lovely summary of Bradley's excitement, moving furniture around. Yeah. In fact, by the way, everyone, we are going to get a factory tour. So hang around to the end of this live stream, because Bradley's going to walk around trying to hold his phone as steady as possible and show you the factory and all the assembly areas and testing and warehousing and stuff. So it's quite interesting. But I got a moment, the other point I wanted to cover off on too was you mentioned that you make the batteries in Australia, but there's still some components that you bring in. What are they?
We source our lithium cells from factories in China. LFP is pretty much been the domain of Chinese manufacturers. There are companies outside of China that build NCA and NMC cells. Simon and I have been to China and we've visited a whole range of factories. It's kind of funny. The way Simon tells how good a particular manufacturer is that halfway through the factory tour, he asks whether he could use their bathroom. And because they're in the middle of the factory, he has to use one of the staff toilets. And so if the staff toilet is clean, he knows that it's a good quality manufacturer. So it's one of the reasons why he likes to go to China to do factory tours.
I never thought we'd get onto toilets in this talk, but yeah, very good. So Bradley, look, I've got a prop here. I believe this is a 186500 cell. You're sort of pretty standard for a lot of consumer toys, but also found in things like Tesla cars and power walls and stuff. Is this what you're using?
We use a cylindrical cell. So some small products will also use the 18650.
Yeah.
However, a lot of our products use the 26650. And for higher energy density, we also use the 32700.
Can you turn them sideways so we can see how long they are too? Just curious. So can you explain those numbers? It took me a while to realise what they meant.
Oh, okay. So an 18650 means that it's a 18 millimetre diameter and it's 650 millimetres long. Same with the 26650 is 26 millimetre in diameter and 650 millimetres long.
I think it's 65 millimetres actually, but yeah.
Oh, sorry, 65.
You'd be a bit long.
He got me all excited as a hand model. And 32 millimetres by 70 millimetres.
So which cells do you use in your product? Which size?
We use the 2650 and the 32700.
So the Life battery uses the 26650 and the Eco uses the 32700. It's a more energy dense cell that we've sourced for the Ecos, and that's why we can get the 4 kilowatt hour capacity as opposed to the 3.3 kilowatt hour capacity in the in the Lifes.
Well, I think mine's bigger than yours. So in fact, lithium cells come in all sorts of form factors, don't they?
Yes.
So
and they'll have their application.
So I've also got what's called a pouch cell here. This is just a little toy one, not the sort you'd find in an energy storage product. This is more like a remote controlled toy, but scale that up 10, 20 times. That would be what would be found in many lithium battery packs. Is that correct?
Yes. The pouch cell is very economical to make. And because of the flat shape, it's easy to pack it together to build batteries. The challenge, though, with the pouch cell is that you don't have the mechanical strength. So you have to manage them more carefully with your BMS, and they're not as tolerant to higher temperatures. So if you're looking for an economical solution, they're quite a good product. But if you're looking, like in our industry where we're looking for robustness and longevity, they're not the format that we choose to build our batteries with.
So the physical robustness of the cylindrical cells, I'm squeezing this, it's got a metal case. I could probably just about stand on it, but should I squeeze this one really hard?
Not when it's turned on, maybe.
It's sort of it's more difficult to have uniformity in the construction of the layers in a pouch or a prismatic cell, where it's a lot easier with to keep consistency in the cylindrical cell. Cylinders are naturally mechanically stronger than rectangles.
What about thermal management?
Again, most of your pouch cells and your prismatic cells will expand with temperature. So when you build a prismatic battery or a pouch cell battery, the cells are actually constrained inside of the case. So you don't get the air gaps around the cells for thermal management. With a cylindrical cell, by their nature, you can't pack them as tightly as you do with prismatic or pouch cell, and so the air gaps then it makes it easier to maintain the temperature in the cells.
Right, yeah, I get the analogies. We've got a question here. I'll probably give this one to Craig. It's from Nick. Now, let's bring it up on screen. Nick says, what's the advantage of higher voltage batteries?
One of the main advantages is you're dealing with smaller currents, really, is what it is. So if you can imagine running, 1,000 amps at 48 volts, that's some pretty heavy-duty cable you've got to have. But, 48 volts at 1,000 amps, you're looking at, 48,000 kilowatts in a sense. But if you're dealing with the same sort of energy at a higher voltage, your currents come down. So you can use, rather than using contactors, you can use relays. Rather than using big, thick cables, you can use thinner cables, basically. So it comes down to current, really, is what it comes down to.
What about the equipment you connect it to?
So yeah, a lot of inverters, once you get into the higher power stream, they do require usually a higher voltage input. Some don't, but a lot of the commercial grade ones do require a higher voltage input. So it allows us to connect into the likes of brands like Cinexcel or and lots of other brands that are out there, CENT and a few other brands out there.
Right. Also, just the cable size, costs go down too if you're wiring something up of not using, 70 or 120 mil cable.
Correct.
So,
yeah. Yep. Definitely.
So it depends on the size of the solution you're hooking up to, because the other side of the things you're going to consider is that at 48 volts, it's ELV. But at 500 volts, you have a different set of regulations and rules and who's allowed to work on the system. So it depends on the size of the application as to whether your focus is on current or voltage.
Right, gotcha. Okay, so moving on through my question list that I've got here. We talked about temperature, and you talked about cylindrical cells and pouch cells and their ability to self-manage temperature. So in terms of ratings, what ratings do PowerPlus Energy batteries have for ambient temperature?
The cells we use are rated to 65 degrees. And so... look, it's similar to a lead-acid battery. The cells actually perform very well at high temperatures, but it has some impact on the service life of the battery, a lot less than what you'd experience with a lead-acid battery. We've found in our own internal testing that up to about 45 degrees, there's no sort of accelerated degradation of the cells, especially if it's a bit warmer during the day and a bit cooler at night. The warranty sort of points to 55 degrees, and that's just to give ourselves a buffer. The other end, if you get down to 0 volts, lithium ferrophosphate doesn't like to be charged. So while you can discharge to minus 20, you don't discharge an LFP cell below 0. But in applications where we've been above the snow line, typically we've found that inside the box, inside the battery case, inside of a garage or a shed or whatever, while it might be minus 5 or minus 10 outside, it's still sort of 5 to 10 degrees inside. And then I guess if it's really a problem, you can revert to the old heater mats to keep the ambient temperature up a little bit. But generally, it hasn't been a problem.
So our voltage window, I guess our temperature window is minus 20 to plus 65 degrees. And we have an optimal sort of temperature range in our manuals that we sort of try and get people to stay between on a regular basis. So the idea is up to 45 degrees, every day is quite fine. But once you start getting above that sort of temperature, you just got to look at how you're, discharging or charging the batteries at those sorts of temperatures. And we sort of recommend a C5 discharge once you get above 45 degrees, up to the 65 degrees C.
Cool. So another question for Craig, just in terms of your market, do you see a particular market for your product, or you've mentioned some applications already?
Look, our products are being used at the moment due to there being a self-managed battery with no communications. They're being used in a lot of the with a lot of the off-grid inverters for off-grid applications. So getting used heavily in anything from as small as 3.3 kilowatt hour systems right up to 0.5 megawatt hour in size systems is what being used in the off-grid side of space. Getting used in high-end hybrid applications and those. the future of the product is to be able to be used across a broad spectrum of markets. So a lot of people on this broadcast at the moment are probably used to just solar and storage applications. However, there's a lot of UPS applications, rail, traction, mobile applications, and those sorts of things that are really targeted by our business with some of the batteries. So even things like telecommunications.
Right. So you mentioned the... Oh, my mind's gone blank. What you mentioned. Sorry, I'll come back to it in a minute. No, I was just trying to read and think and talk at the same time, which is really not the best thing. We were talking about the market, and you've got a range of market opportunities for the product. But what are you planning? Any new products? It's something, can you give us any sneak previews?
Look, there's some sneak previews, I guess, to a degree in some of the things that we do already. So the Life 120 has a smart BMS in it. So that there has an Australian-made BMS inside that we've developed ourselves. That will essentially be rolled out into the other batteries, the 48s and the 24s as well, to give them a smart battery option. They would also still be able to be installed with the self-managed batteries as well. So Series 1 of the batteries, they'd still be able to be installed there for backwards compatibility. But it gives you some array of functionality, which is data and monitoring out of the batteries. And then, of course, you've already showcased the high voltage side of things, which will give us the ability to get into more modular style systems.
You just reminded me. It was what is self-managed versus not self-managed.
Yeah, so self-managed versus non-self-managed. So the best way of explaining that is something that is what they class, I guess the industry has termed it as managed, is a battery that usually has... may have modular batteries that stack up, but they would have a BMU inside the battery and a BMS usually separate. And the BMS would then usually communicate with the connected PCEs, be that the MPPTs, if they can DC couple, or whether that's through the likes of the inverters.
Whoa. There's a lot of TLAs flying around there, 3-letter acronyms. Can you just expand on each of those? So you went BMU is...
The BMU is a battery management unit, so that's the one that looks after the individual battery itself. And then you've got the BMS.
Yep.
The BMS then looks at the whole as a whole. So a lot of battery systems have gone for having a BMU in each individual battery and a BMS that then talks to all of the BMUs to understand what's going on. And what the BMS would generally do then is if one of the batteries has a problem reported by the BMU, they would shut the whole string down. They also need to be able to communicate to the inverters as well, whatever's charging or discharging. So they would be reporting things to the inverter's temperature, what you can discharge, what you can't discharge, can you charge, can you not charge, and the inverter would back off accordingly to protect the battery, in a sense. And the managed battery variety really came from the use of pouch cells in the market. So some brands were the fastest first to market. They were using pouch cells because of the markets they were in already, which was electric vehicles and mobile devices. They really wanted to control the temperature ratings of those cells inside. As Bradley mentioned before, pouch cells are very hard to control the temperature. So they really needed to have granular control of the inverters. And you would see that with the likes of Selectronic when they're connected to some inverters, they heavily derate. With a self-managed battery, it's a little bit different the way that we've gone about doing it. So each battery has a BMU and a BMS inside it, I guess you could say. So each battery looks after itself, temperature and all those sorts of things, doesn't report to the next battery, and it doesn't need to be connected to the inverter for communication. So the inverter can still go on its merry way, do what it's got to do, state of charge control, charge or discharge as heavy as it likes. And if the batteries feel that they've got an issue, individually they can pull themselves out of the circuits and the rest of the batteries will keep operating.
Great. Well, I think you've just given me a segue to the next topic I wanted to cover, which was remote monitoring. Now, even though your batteries are self-managed, I believe you have a monitoring solution for them as well.
Correct, we do. So we've got the Powerlink. Bradley, did you want to talk more about the Powerlink?
Oh, sure. As Craig has just mentioned, even with our new digital BMS or our smart BMS, we didn't want to take away from the ease of use and the reliability of a self-managed battery. So our Powerlink module is basically polling the batteries to gather the data. Again, that could be voltage and current and temperature and the health of the BMS. And that information is then forwarded to a cloud service so that you can view it and there'll be future features that'll be added to that. But it doesn't take away from the unit being self-managed.
So what I've brought up on screen actually is the performance.powerplus-energy.com.au interface for the batteries I've got here at the lab. So these are 3 120-volt batteries. So when I hover over the line, I can actually see the at quite a granular level things like current, temperature, voltage. I'll just go to the top here. So there we're looking at current on each of those battery modules. And I believe that for your R&D people, you've got a level of monitoring even deeper than that.
Yes, we have quite extensive data that we can pull off the battery to look at how it's performing, if anything needs to be tweaked. And the idea is that we want the user to have a better experience. So if we can pick up any early warning signs of problems within the battery, rather than it turning into a warranty claim, we can sort of talk to the customer or the installer and get them to tweak things so the battery's used to its optimum. And you'll notice there on the right-hand side, you've got the 3 columns for each of the batteries. So you can look at your maximum and minimum and current values for each of those batteries. So we can also look at that on a cell level as well.
Wow.
Down the bottom, you've also got your maximum, minimum, and actual temperatures. So we're monitoring the temperature in the cell pack and on the BMS board.
Well, let me just go to a colder period. So last 7 days, we've had some cold weather. And what did we get down to? 7 degrees? Yeah, it was actually snowing here. So that sort of reinforces what you said about that there's a certain amount of thermal inertia in a battery pack anyway. So even though outdoors it was 0 degrees all day, the batteries never got below 7, and they're only in an open shed. So they're not in an insulated, warm, cosy place.
And one of the things that is a big benefit to installers is when a customer calls up and says, oh, my solar system's not working or my inverter's not working, by having access to historical information about the amount of PV and the size of the loads and what the batteries are doing, makes it a lot easier for installers to provide remote support rather than rocking up on site with a multimeter and trying to work out what the battery's been doing for the last 6 weeks.
Cool. Now, we're going to do a little change of tack here. I'm going to disconnect Bradley, not because I don't like him, but because he's going to give us a factory tour. But Craig's going to take over. I'm going to throw a few questions at Craig while Bradley gets his phone ready and gets in position, and I'll add him to the call. So we'll just say au revoir, Bradley, for the time being. You'll be back in a minute. So Bradley's out and Craig's back. Now, Craig, I'll get my picture back on there. Here we go. I'm going to work out how to call Bradley. It's fun
You're doing 2 things at once again, Glenn.
Yeah, I'm doing 2 things at once. Probably 3 or 4. And Craig, so on my list of questions, we've covered expandability. Geez, we've covered thermal management. Now, software, I just showed that remote monitoring. Is there any software you need to have or any special hardware other than the batteries for them to work?
No, there's not. So the batteries essentially just work is what they do. So there's no other software or hardware that you do need. So if it's a DC powered system, essentially you can go. But of course, you need something to charge it and something to discharge it and convert the energy if it's an AC, or you need to be able to charge it in some way, shape or form. So no, the Powerlink is an added bonus. So it's not mandatory across the smart BMS to have that. However, we do encourage it for people because it does give us the ability to remotely support them as well. So if we can see what's going on with the system while they're on site, it's definitely an advantage for us to be able to support them long term.
Right. Okay, I'm just having a go at trying to bring Bradley in. So while I think I've got him. Are you there, Bradley?
Yes.
Hey, we did it.
Here.
All right, so we're going to just bring Bradley and his walkabout talkabout up on screen. So let me just do that. Where are we, Bradley? There you go. So you turn this phone sideways. That's great. Oh, wow. So you're in the lounge room.
Oh, yeah. Well, Craig wasn't joking when he said that Bradley and his family like to go to IKEA. So half the furniture in here is is from an IKEA. We look like an IKEA showroom. So yes, as some of you may know, we started out 3 or 4 years ago with a 3-metre storage shed at Kennard Storage, and 2 years ago we moved into a 200 square metre factory at Bayswater, and because Craig was selling too many batteries, we had to move into part of the old Siemens site. So Siemens on Mountain Highway at Bayswater had 2 manufacturing facilities out the back, and because they've moved offshore with the manufacturing, it was a perfect opportunity for us to move in. So this is a coveted corner with all the natural light, the windows. Our office staff work out here, so the lovely Amy and Jen. This is their home. No one's allowed to enter without their permission.
So they usually guys don't know Amy and Jen. They're our customer service team. So, lead times, deliveries, dates, and all those sorts of things. That's where the hub's done.
So this room here is Craig's office. Notice the lights are out. In Bayswater, we had a power failure on Thursday night, and so we haven't had power for parts of the building. Some of it came on yesterday morning, and the electrician is coming tomorrow morning to fix up the rest. So part of the area here we use for doing some promotional videos. This used to be manufacturing. We've recently leased another 1,300 square metres. So this is going to become our product development and research area. So one of the things that we're working on is that with different brand inverters, we are testing the batteries, and that way we can write better documentation to make it easier for installations. And we're working with different companies so that our battery settings will be available in their drop-down menus. So this is one of the Schneider XW Pros.
That's the new one.
Yep, that's a new one with their. So that got delivered to us last week. This is one of the testing stations for our 24 volt and 48 volt. We use the Victron, and
so the testing station was wheeled out to power the office basically while we had the blackout. So usually it's obviously not in the area there.
No.
One of the advantages of being a battery company.
Having a play with the Inga team, we do a lot of work with the Selectronic. We've recently been given a SunGrow that we're testing. We've got an SMA and a Goodweed coming so that we can test the different products.
Now,
I'll head
Brett,
off now.
while you're walking, I'm going to just cut over to Craig because we've got a question. So you can just do a bit of a walk, and I'll grab you in a second. So, hang on, where's Craig gone? There he is. No.
I'm still here.
Oh, Craig's still there. Sorry, just got to bring Craig up. There you go. The question comes from Jeffrey, and it is this monitoring available on both the Eco and the Prem? I guess Prem means the Life.
Premium. At the moment, only in the 120 volt on the Life Premiums is available. So generation 2 of the battery will be available in the 24 and 48 volt Life. And at this stage, most likely the Eco. We haven't made a final decision on that. However, most likely, yes. We have been releasing the 48 volt Premium and the 48 volt Eco onto projects using the Smart BMS. So it's been rolled out onto probably close to about 1,500 batteries have been rolled out onto site using those using the Smart BMS, and it's given us a lot of real life sort of field testing at the same time as in the lab.
Second question is from Ian. Ian asks, can Powerlink be integrated locally on site rather than a cloud access, i.e. off-grid?
Yeah, so at the moment for end user access, of course, we basically it's through the cloud. It does have local RS485. It's also going to have SNMP, Modbus, and CAN bus integrated over the next sort of few months. So there's going to be multiple ways that you can communicate with it. Locally for the consumer, I haven't really thought in great detail about that, but at some stage we'll probably utilize one of those platforms so that it can be viewed locally.
Great.
Not that I'll admit this in public, But on the drawing board is we'll have support for a local HMI interface. And so but that'll be next year before that's released. So currently we're trialling Modbus. S&P library will be added in the next 3 months. And we're also looking at supporting CAN bus, the Sunspec interface on CAN bus. So it'll be fairly universal.
So we're back to our roving reporter, Bradley Paton. Now, where are you now, Bradley?
Okay, this is, excuse the fact we don't have power, but this is our sub-assembly area. So we have, we've got our first row of benches in on the side here. All of our sub-assemblies, so everything gets made up and bundled into groups of 10, and then before it goes into the battery assembly area, we have 2 rooms here that are used for our BMS programming and quality control. Everything that we make, every single cable, every single termination comes through our QA area. So every single cable, every assembly is all checked before it goes into the battery assembly area. So we're implementing preparation for ISO 9001. So we have a check sheet for everything that's built, and before it heads off into the production area. So everything we do will be traceable, so that we're compliant with ISO 9001. We just finishing off our IEC testing, and next year we'll have our UL listing as well. So that's the production, that's the pre-assembly area.
And where are we off to next?
All right, so this area is currently our R&D area. It's being stripped out next week to allow production to expand into here. So again, apologies for the low light, but in here we do all of our testing on the digital smart BMS. Apologise, Glenn. But this is our high voltage testing area.
Yep.
We have 4 engineers that work for us, and they're doing the development and testing work on the new BMS designs. So they get to come in here and play. This is sort of a production run of the Powerlink modules.
The Powerlink being the remote monitoring,
yes,
or even
yes,
local monitoring. Yep.
So this way we've got we're getting the builder in so that we've got an easy workflow through from our pre-assembly area through to assembly and then final testing.
So what are those yellow stripes for? Is that for the kids on their go-karts?
No. That's production's attempt to stop me from taking shortcuts through. That's sort of the production area, but they want me to stay out of their way.
So the signs say, Bradley, stay between the yellow lines.
Something like that, yes.
Yeah, so basically, if you're not a part of production, you should stay on the walkways. If you're a part of production, of course, you can gear through and go onto the production floor.
Gotcha.
Yeah. So out here we have our main work area for the battery assembly. So each of our staff have their own work trolley. So with COVID-19, we've had to buy, everyone has to have a complete set of their own tools. We currently have 5 workstations, but in the new area we'll have 12 workstations for building batteries.
What are all those cardboard boxes?
They're the cell packs that come in, the cells that come in out of the warehouse.
All right.
So we're trying to streamline everything so there's less handling. So previously, everything would have to come off, we'd unpack the pallets in the warehouse, but now we're bringing the pallets all the way in. As I mentioned before, every battery that we build, this is our test room. Some of our test inverters are out of the room. I'll explain in a minute why, but every single battery we charge and discharge, and we check with the thermal camera for loose connections, for dry solder joints, or for poor welding. And once it comes out of there, It comes
It's usually very pretty in there with lots of inverters in there, but of course, it looks pretty bare in there at the moment, doesn't it?
So it comes out here for lidding and final inspection, but because we had the power outage on Thursday night, one of our neighbours is a biomedical lab, and they had critical fridges and freezers that they'd lost power for, and they had to wait about 7 or 8 hours before they could get a generator. So we put 6 of our test inverters on trolleys and wheeled them down there so they could run their fridges, so they didn't lose their samples. So they actually do COVID testing as well.
Wow.
So we were able to get them set up within about 15 to 20 minutes. And so we've just wheeled them back in here. Monday they'll go back on the benches. So
there's a lot of blue. You must be one of Victron's biggest customers.
Look, the Victron inverter had the features and the price that we needed initially to do the testing. So because basically we're just doing a charge and discharge cycle, and yes, I mean, I remember selling Victron product like 25 years ago, and it looked the same as this. So maybe I'm just stuck in my ways with the colour.
The Victron product is, of course, it's very easy for training production staff on how to use it. So it's a very simplistic design like that.
Well, there's more. Where are we going now? Next door.
So this is our front warehouse.
Wow.
So off to the left here, I mean, other than lockers in the lunchroom, this is an area where we assemble all of our cabinets. And you can see here, there's some of the PF9s ready to go out.
Should point out to people who've just joined us, the power's off at your facility because there was a big storm in Bayswater last week.
So metalwork all comes in from a local manufacturer. I mean, we could get it at nearly half the price out of a factory in China. However, we've just found that with consistency and quality, that working with local suppliers is better. Here in the warehouse, we're just getting ready. We've got another 40-foot container for export going overseas next week. So we're just getting ready for that. As Craig said, we're gradually moving to bus bar systems in our products. Again, locally made bus bars. And there's the eternal question as to should the circuit breaker be behind a closed door or outside? And I don't want to know your answer, Glenn.
Readily accessible.
This is everyone's favourite toy, the little red chariot.
PowerPlus energy batteries in that?
Apparently I'm banned from using it.
Okay.
So we've just got 3 40-foot containers due in a week or two, but we just this is stuff coming in and ready to go out. We've recently just expanded because we were running out of room, and we have a new warehouse out the back.
You just keep knocking holes in the wall and finding more warehouses.
Well, we're trying, as you can see at the back, there's a temporary door over the next roller door, and we're trying to encourage our neighbours to move out.
I can see why you moved out of that Kennard hire storage unit.
Sorry about that.
He missed that
If he
one.
stayed at the Kennard Hire one, he'd actually be leasing all of the facility by now. So
When we left there, we had 5 units. So when my wife came to help look after the books and keep me in line, she got sick of walking between all the different units. So here we have all the cabinets prepped to go out.
So, Bradley, I think we've probably had enough walk around. I'm feeling a little bit seasick, actually. But is there any other bits that you wanted to show us before we let you sit down and we'll just get ready to wind up the session?
Look, just sort of we're working with different companies on different projects. So these are some outdoor modular solar UPSs with modular MPPTs and rectifiers and inverters. So,
IP50 something?
Sorry?
IP50 something?
Yes, IP56, I believe, or IP54 to go outside. They've been going up onto mine sites. We have another customer we're working with where we do lighting trailers.
Oh, nice.
So, and we're sort of working with generator hire companies to do mobile skids. So using 3 SP Pros or 3 Victron Quattros or 3 Schneider XW Pros, you can have a mobile 3-phase grid generator support with 160 kilowatt hours of battery.
Great.
So yes. So I'll turn my video off and so that you don't get seasick.
And I'll probably just go back to Craig while you go and sit down and get yourself comfortable. So we've always Craig on. There he is. Got Craig back. Craig, yeah, it's right. He's still there. You're the person who's not making me seasick wandering around. So I really appreciate the tour, though. That was a good way of looking at that facility. And even though the lights were out because of a storm, so we've had someone. Jeffrey says thanks for the tour. So yeah, it seems to be appreciated. And Mansingh also says really informative session. So thanks, guys. Feel free to ask some more comments. We're going to finish in a few minutes, so if you've got any last questions, now's the time to put them into the comments on your feed. So just changing topic completely now for a moment. Just wondering how you think the solar and battery industry is going, Craig?
At the moment, it seems to be going quite well. Of course, Melbourne's struggling a little bit for installation side of things because you can't physically do any installations. But as a whole, we've never been busier. So over this whole COVID time, whether it's invigorated people to upgrade their systems because they're spending more time at home, or whether it's invigorated people to put those systems on some of their holiday properties, I don't know. But we've never been busier in the last sort of 5 months than we ever have been. So. And some people may see that with some of the supply that are going out into the market at the moment. So we're at about a 4-week lead time, where we were originally 5 to 10 days. But yeah, I think it's been quite buoyant, and I don't think it's going to get any quieter.
Cool. I don't know if you saw the Smart Energy Council had a little poster which had a picture of a family in a brightly lit house, and it said invest in energy that you can store, and then compared to investing in toilet paper. And there's another family sitting in a dark house with a candle with lots of toilet paper around them. I thought it captured the sort of the appeal of energy storage. It's energy that you can use. It's a real value to have. So we've got Nick also says thanks. Very good factory tour. So yeah, thanks there, Nick. Have we got you back, Bradley? You're sitting there somewhat comfortable?
Yes.
All right, There you are. Gotcha. So, look, just crystal ball gazing, the future. What do you think is going to happen? Is lithium going to be the battery chemistry for the next 10 or 20 years, or is there something else on the horizon you think is going to replace it?
There's a lot of research going on with different types of energy storage. Most of them are still very much in the laboratory stage. So when it comes to batteries, I mean, one of the advantages of working with our new BMS is that we're fairly flexible. So if we wanted to look at lithium titanate or NMC or NCA or other chemistries, if the application required that, we can. I think that solid state lithium is most probably going to be the next focus on energy storage. However, again, looking at the application, it might be hydrogen fuel cells. It might be, there's lots of different. I mean, you held up the lithium titanate cell before, and you look at lithium titanate. You look at its characteristics. It's got great temperature tolerance. It's got great cycle life. However, its energy density is very similar to lead acid, and its expense. It's sort of 30, 40, 50% more, or 100% more expensive than your average LFP cell. So if you're going to do FCAS, sure, you'd look at a different chemistry than LFP possibly. But I think that LFP it's not the best at anything, but it's good at everything. So it's a nice, comfortable, middle-of-the-road energy storage solution. I think for the next 5 years, it's still going to be most probably the go-to chemistry.
Okay, so Craig, do you think as a company you're fairly chemistry agnostic, though lithium does it for you right now? LFP is the right choice?
Yeah, most definitely. For if you look at the price of LFP, it's slightly more expensive than NCA or an MC, but it's still within the ballpark. Has better performance characteristics and safety aspects with the chemistry as well. And when you're talking about stationary storage, we don't need to worry about energy density quite as much as what you do in vehicles. So vehicles use obviously NMC and NCA for the energy density. However, it comes with some inherent temperature concerns and possible fires and those sorts of things. So staying with LFP is to me a great chemistry to sort of stay with. And I don't think battery storage is going to change much over the next 5 to 10 years with chemistry change, but it's definitely only a stopgap, I think lithium is. So lithium is a stopgap before something else is going to take over.
Right. We've got one last question from Idris. Idris says, in terms of training for new installers, one-day training, I guess he's asking, are you going to be providing some training courses on your product?
Hey, batteries are so easy to install, you don't need training.
Yeah, look, there is that aspect of it. I mean, it's basically with the installation, you wheel your cabinet into position, slide your batteries in, connect to the DC bus bar, put the feed on and close the door, and you're pretty much done. So it's not really a huge detailed sort of side of things. However, we are developing some videos. So the first thing to sort of come up, you'll start seeing on our webpage come out will be some short videos. It's more about general sort of stuff, 1 to 2 minute sort of video shots. However, we are developing a lot of presentations at the moment that can be used for training internally and also be taken to train externally. So yes, we will be running some training at some stage. It's just whether or not it's this side of Christmas or whether it's the other side of Christmas at this stage. With the COVID side of things and also the growth of the company, it's at this stage, it's finding the time to put into those sorts of things to make them worth for people. So we are spending a lot more time on them as we sort of hire more staff, but it's been a bugbear for a little while.
Cool. Well, I think we've exhausted the questions from the audience, and we've been going for about an hour and a quarter now, so you're probably feeling a bit tired too. Really appreciate the time you put into talking to me today, and I've learned a lot, and I'm sure our audience have as well. So if they need to find out more, I guess they can always go to the PowerPlus Energy website. That's powerplus-energy.com.au to get more technical detail and make contact with you guys.
Correct, they can.
All right, well...
And if they want to come to my place in the next 15 minutes, I can smell the roast dinner cooking, so it should be served up by then.
Oh, great.
Been accused of liking to the sound of our own voice on the phone.
All right. Well, thanks, everyone. Thanks to everyone who attended today. And like I said, this will be available on YouTube in about an hour or two as well, so you can watch it there or send it on to other people. Usual story with YouTube. Don't forget to press the like button if you like the video, and subscribe if you want to hear more of this content. I'll be doing weekly. I've been doing it for about 3 weeks now on a Sunday at 2 o'clock Melbourne time, interviewing people, talking about tech stuff. So, yeah, come back to this channel for more content. So thanks, everyone.
Thanks.
Okay, bye.
Bye.